So in the last class, we finished till question number 8. So we'll start from question number 19. So a bag contains 6 red marbles, 3 blue marbles, and 5 green marbles. If a marble is randomly selected from the bag, so what is the probability that it is blue? So we have 3 blue, 5 greens, and 6 reds. So how many totals? And if a marble is randomly selected, so we'll select just one marble. So that's mean the total is 6 plus 3, 9 plus 5, 14. So in the denominator we have total, which is 14. And in our favor, so we want to randomly select on blue marble, right? So how many blues we have? 3. So it will be 3 over 14. So the answer is 3 over 14. So this will be the answer in this case. Okay, so find the indicated probability by using the general addition rule. So you already know the addition rule. So we'll be for solving this problem, so you need to use the addition rule of probability. Okay, just to clarify, you are dropping the lowest homework grade, right? Yes, I'm going to drop the 3 lowest homework grades. Okay, so here we are given probability of A, which is 0.5, and we also have probability of B and probability of A and B. So we have to find probability of A or B. So the addition rule is probability of A plus probability of B minus probability of A and B. So this is the addition rule. So we have all the information. We have probability of A, which is 0.5 plus 0.33 minus 0.15. So that's mean this is 0.35, 0.68. So the answer will be then 0.68. So if you simplify this one, then you will get 0.68. Okay, so the next question is, suppose that 2 balanced dice, a red die and green die, are rolled. So why denote the value of green minus the red? So here y is the random variable, and which represents the numbers we'll get from the green die minus the numbers we'll get from the red die. Okay. So what are the possible values for green? Possible values for greens are 1, 2, 3, 4, 5, and 6. And similarly, for the red one, the possible values are 1, 2, 3, 4, 5, 6. Okay, so what should be the minimum value for y? Green minus red. So the minimum value for green minus the maximum value for red. So 1 minus 6 is -5. So the minimum value we can have is -5. So that's mean the possible values will be then -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5, right? The maximum value could be 5 because green minus red. So if you consider green is 6 and red is 1, then it will be 6 minus 1. So the maximum value is 5 and minimum is -5. So y is -5 to 5. So the answer will be then this one. Do you have any question? Yeah, this is the correct answer. Okay, the following table displays a frequency distribution. So we have a frequency distribution for the number of living grandparents for students at a high school. So for a randomly selected student in the school, X denote the number of living grandparents of the student. So X is the number of living grandparents of the students. So what are the possible values? So the maximum could be 4, right? And the minimum is 0. So that's mean the possible values are 0, 1, 2, 3, 4. So obtain the probability distribution of X. So we have the frequency distribution. So we need to find the probability distribution. So what is the probability distribution? The probability distribution is values of X and corresponding probability. So when X is 0, the frequency is 40. So it will be then 40 divided by the total. The total number is 40 plus 73 plus 158 plus 212 plus 148. So if you add them together, then it will be 40 plus 73 plus 158 plus 212 plus 148. So 631. So 40 divided by 631. So the first number is, for 0, the probability is 40 divided by 631. So that's been 0.063. So this probability is 0.063. And similarly, you have to find the probability corresponding to value 1, which is 73 divided by 631. And similarly, probability for X equals to 2, it will be 158 divided by 631. Okay, so for 0, we have 0.063 only for this one. So this is the correct answer. So this is wrong, this is wrong, this is wrong. So the correct answer is A. Okay, the random number variable X is the number that shows up when a loaded die is rolled. Its probability distribution is given in the table. So we have the probability distribution. Find the mean of the random variable and round to 2 decimal places. So we have to find the mean. So we have the probability distribution, and finding mean means we have to find the expected value of X. So expected value of X is summation of X times probability of X is equal X. So that's mean we'll multiply probability with the values of X and add them together. So that's mean 1 times 0.13 plus 2 times 0.16 plus 3 times 0.1 plus 4 times 0.1 plus 5 times 0.14 plus 6 times 0.37. So if you add them together, then it will be, I think, 4.07. So 0.13 plus plus 6 times 0.37. Yeah, 4.07. So the expected value is 4.07. So here the expected value is 4.07. Yes, this is correct answer. Okay, so frequency data were reported for the ages of women who became mothers during 1 year in a selected US city. The age distribution is given in the table. So we have the frequency distribution here, and the ages from 10 to under 15 is the frequency is 10, and 15 to under 20, the frequency is 87. So we have the frequency distribution. So now we need to determine the shape of the distribution. So how do we determine the shape of the distribution? So we need to construct a histogram, but for this one, you do not need to construct histogram. But so the height is, okay, so let's consider this is 10, this is 100, this is 200, 300, 400, 500, 600, 700, and 800. Okay, so for the first one, the height is 10, so it will be here. And for the second one, the height is 87, so somewhere here. And for the third one, the height is 888, so it will be here, right? Even it will be actually above this point. So, and the next one is 679, so which is here. Then 245 will be here. Then 227 will be here. And then 123 will be here. And 79 will be here. Okay, so now if you connect these dots, then it will be the shape of the distribution will be something like this. So this is actually the rough graph of the frequency distribution. So what do you think? So is it right is skewed or left is skewed or uniform distribution or bell shaped? So what do you think? The shape is actually something like this. So what do you think? Is it right is skewed, left is skewed, or symmetric? This is right is skewed, right? Yeah, that's correct. Because we have a long tail on the right side. So that's mean this is right is skewed distribution. So the answer will be, no, the distribution is right is skewed. Yeah, this is the correct answer. Okay, the next question is use a table of areas to find the specified area under the standard normal curve. So the area that lies to the right of 0.59. So we need to find the area under the normal curve. So if this is the normal curve, standard normal curve, so we need to find the area to the right of 0.59. So this is 0.59 will be somewhere here. So now we need to find this area. So how do we find this area? So use the Z table. Okay, so if you look at this table, then this is 0.59. So if you look at 0.59, okay, so this area is same as the area on the left side of negative 0.59, right? Because it is symmetric. So if you just look at negative 0.59, you'll get the area on the right side of 0.59. So we just need to look at negative 0.59. So this is negative 0.5, and the second decimal place is 9. So 9 is here. So that's been 0.5 and 9. So this is 0.2776. So the answer is 0.2776. So this is the correct answer. Okay, similarly here, use a table of the areas for the standard normal curve. So we need to find the Z 0.7. So we need to find Z score where the probability is 0.07 or the area on the right side of the Z score is 0.07. So that's mean if you do the normal curve, we need to find this one where this area is 0.07. Okay, so the area on the left side is then 0.93, right? The total area is 1. So the area on the left side is 0.93. Okay, now look at the normal curve. Okay, so the area is left, the area on the left is 0.93. So we'll look at 0.93. So where is 0.93? This is 0.989493. Yeah, this is 939306. So this is between these two numbers, right? 0.9292 and 0.9306. And corresponding z score is 1.47 and 1.48. So that's mean the z score will be, it is 0.93 is closest to 1.48. So we'll consider the z score is 1.48, or you can take the average. But here they didn't take the average, they considered this is 1.48. So that's why the answer will be then 1.48. Okay, so the diameters of bolts produced by a certain machine are normally distributed with a mean 0.30 inch and the standard deviation is 0.01. So the mean is mu is 0.30 and standard deviation sigma is 0.01. So what percent of bolts will have a diameter greater than 0.03 inches? So we have to find the probability where the diameter, if x is the random variable which represents the diameter, then we need to find x greater than 0.32. So we have to find this probability. So to find this probability, first you need to convert this number to a standard. You need to standardize this value, right? So what is the formula? The formula is x minus mu over sigma. So the value of x is 0.32 minus mu is 0.30 and sigma is 0.01. So if you simplify this one, then the z score will be 0.32 minus 0.3 divide 0.01. So which is 2. So that's mean we need to find the probability. Now we standardize, so it will be z greater than 2. So we need to find this probability. Okay, so I think it will be 2.28%. Or you can look at the z table. Yeah, let me check. The probability where z greater than 2 is this one. Yeah. Or you can look at the z table. So if you look at 2, then it will be yeah, if you look at -2, you will directly get the probability 2.28%. Do you have any question? Okay, so the amount of Zen's monthly phone bill is normally distributed. The mean is mu, which is 54, and standard deviation sigma is 11. So we need to find the first quarter, Q1. So we have to find the value of Q1. So how can we find this one? Okay, Q1 means this area is the area on the left side is, this is the first quartile. So that's been 25% of the observations on the left side. So the area is 0.25. So from here, you will get the z score, corresponding z score. So you'll get the corresponding z score from here. So if you look at this area, 0.25, you will get the corresponding z score. And you will use that z score to find the value of, to find Q1. Okay, so we know that z is equal x minus mu over sigma. That's mean you have to find the value of x. So x will be then mu plus sigma times z. Okay, from the z table, if you look at 0.25, you will get the value, you will get the z score corresponding q1. Then you will use this formula to find the value of q1, x equals to mu plus sigma times z. So you will use this one. Okay, so the answer will be, so you should find it, okay? Or I can also show you. We need to find the z score corresponding 0.25. So look at the z table. So we have the z table here. Okay. So 0.25. The area is 0.25. So where the area is 0.25, 0.25 is here in between 0.2483 and 2514. So the 0.25 is in between these two numbers. And corresponding z score is negative 0.68 and 0.67. So that's been negative 0.675. So the corresponding z score is negative 0.675. Okay, so let me go back to the question. Yeah. So the corresponding z score is negative 0.675. So now we'll plug in all the numbers here. 54 plus 11 times negative 0.675. So then it will be 54 minus 11 times 0.675. So this is 46.575. So that's been, or here we have actually 46.63. So this is the closest one. So the answer will be then 46.63. Yeah, this is the correct answer. Okay, so now in this question, we have the mean and standard deviation. So we have mu is equal 104, and we have the sigma values, which is 14. So now we have to find the, for the sample size n is equal 49, we need to find the mean for x bar. So that's been mu x bar, and we have to find sigma x bar. So we know that mu x bar is mu and sigma x bar is sigma over square root of n. So this is 104, and this one will be then sigma is 14 over square root of 49, which is 2. So that's mean the standard deviation of x bar is 2 and mean is 104. So the answer will be then D. So the correct answer is option D. So this is the correct answer. Okay, the next one is one truck from Lakeland Trucking Incorporation can carry a load of 547.4 pounds. So records show that the weights of boxes that it carries have a weight of 74 pounds. So that's mean mu is 74 and standard deviation sigma is 28. The sample size n is 49. So we need to find the mean and standard deviation. So that's when we need to find mu x bar and sigma x bar. This is mu, which is 74, and sigma x bar is sigma over square root of n. So that's been 28 over square root of 49, which is 4. So that's been this, and the answer will be option B. So in this case, the answer will be this one. Okay, so in this question, we have also the scores on an aptitude test are distributed with mean mu. So we have the mean mu is 220, and we have the standard deviation is 30. So the shape of the distribution is unspecified. So we do not know the shape of the distribution, whether it is normal or any other distribution. We do not know the distribution, right? So what is the probability that the sampling error made in this estimate? Okay, so the random sample, the sample size is 50. And okay, and the test score will be at most 5 points. So the sampling error will be at most 5 points. So that's mean actually by the mean of random sample of 50. So that's mean we need to find actually this one. The sampling error will be, so we need to find this x minus x bar minus e and x bar plus a. So and the maximum is will be at most 5 points. So that's mean that E is at most 5 points. So now you need to find the probability. So you have to find the probability of X bar. So if you simplify this one, then it will be actually if you add because I did the opposite. So it will be actually this one. X bar is and maximum is 5 point. So that's mean mu plus E and mu minus E. And you have the value for mu, and you have sigma, and you have the sample size 8. So you need to find the probability. So here the maximum sampling error, so that's mean E, the maximum E could be 5 points. So now we have to find the probability of X bar. Yeah. Okay, in the next one, so you have a random sample of 15 asthmatics yields the following data on forced vital capacity in liters. So you have the data set. So you have 15 observations. So the sample size is here, N is 15. And you have used the data to obtain a point estimate. So you need to just find the point estimate of mean mu. So the point estimate is X bar. So that's mean basically you have to find X bar. So X bar means you will add all the observations together and divide by 15. So if you add them together and divide by 15, then you will get the point estimate. Okay, so in this case, you have to just find the sample mean. Yeah, that's it. Okay, similarly here, assuming, okay, so let me read the question first. So we have 205 students. So a survey revealed the amount of pocket money held by each student in a sample of students from statistics 205. Sorry, this is the course number. And we collected a sample here. So we are assuming that sigma is 2, the standard deviation is 2, and find the 99.74% confidence interval. So we have to find the confidence interval. So here we have the data. So we have to find the confidence interval for mu. Okay, so how can we find the confidence interval for mu? So the formula is x bar plus minus. So can we use here z interval? Yeah, the first question is, can we use here z interval? Reveal the amount of pocket money held by the student. The amount are this one. So what is the sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For 15, right? Yeah. So n is 15. Okay, so we have to find a confidence interval for population mean. Actually, here we cannot use because the sample size is not large and we do not know the shape of the distribution, right? So we do not know whether the distribution is normal or not. So that's when you have to use t distribution. So here it will be actually t alpha over 2. Okay, so one more thing here. We know the sigma value. So if sigma is known, actually we can use the distribution. It depends on whether sigma is known or unknown. So sigma is known, so that's when we can actually use z distribution. We do not need to use t distribution. But if sigma is unknown, in that case you have to use is instead of sigma. In that case you have to use t distribution. But here, since sigma is known, so you can use a z interval. So that's been x bar plus minus z alpha over 2 sigma over square root of n. So what is the value of alpha? Alpha is 1 minus 0 0.9974. So this is the value of alpha. So 1 minus 0.9974. So this is actually 0.0026. So alpha over 2 will be then 0.0013. So you have to find the corresponding z score where alpha over 2, the area is 0.0013. And you have the sigma value and you have n, then you can find the confidence interval. And you have to also calculate x bar. So you have the data. So calculate the average and that will be x bar. Do you have any question? Okay, so I'm not going to solve this one. So I am just giving you the idea how to solve this one. Okay. Any question? Okay. So if you do not have question, then let's move to the next question. Based on a sample of size 44. So here the sample size n is 44. Okay, 95% confidence interval for the mean score of all students. So we need to find the 95%. So we are given actually the 95% confidence interval. So find the margin of error. So we have the confidence interval. So confidence width, then the width of the interval is 71.2 minus 64.8. Which is 71.2 minus 64.8. So this is 6.4. Okay, now we need to find the margin of error. So what do we know about the relationship between margin of error and width? The margin of width is the 2 times of the margin of error. So that's mean 2 times E is 6.4. So then E will be 6.4 divided by 2. So which is 3.2. So the answer will be 3.2 in this case. Okay, so here we have 88 chicken eggs and 88 chicken eggs tested in the laboratory and found that the mean amount of cholesterol was 183 milligrams. So the sample size n is 88 and the average is 183 and sigma is 14.3. So construct okay, so and found that the mean amount of cholesterol was 183. So now we need to construct a confidence interval and 95% confidence interval for mu. So x bar plus minus. So what is the sample size? 183. And sigma is known, so we can use z interval. Z alpha over 2 times sigma over square root of n. So here x bar is 183. Now we need to find alpha is 1 minus 0.95, which is 0.05. So alpha over 2 will be then 0.025. Now you need to find the z alpha over 2, and you have the sigma value, you have a square root of n. So x bar is 183 plus minus, you need to find this value z 0.025 from the z table. And we have this is 14.3 square root of 88. Plus 183. So it will be then, I think per C, or you can check actually. You can find this value. Maybe it will be this one. I'm not sure though, but you can check. Yeah. The answer is C for this one. So Z alpha over 2 is 0.025, which is I think 1.96, or you can look at the Z table. Yeah. Okay, so the next question is scores on a certain test are normally distributed. So it is given that the distribution is normal with a variance. So that's mean the sigma square. Sigma square is 73. So our researcher wishes to estimate the mean score achieved by all adults on the test. So find the sample size. So we need to find the sample size needed to assure that with 95% confidence. So we are 95% confidence. So that's when alpha is 0.05. So alpha over 2 is 0.025. Okay, so how do we, and the maximum margin of error, the sample mean will not differ from the population mean by more than 2 units. So that's when the margin of error is 2 units, right? So we know that the margin of error is z alpha over 2 sigma over square root of n. So that n will be then z alpha over 2 times sigma over e square. So here we have the value of alpha over 2, 0.025. Find the corresponding z alpha over 2 and sigma square. Sigma square is 73. Variance is 73. So sigma will be then square root of 73. Okay, so 1.96 square times 73 divided 4. So it will be actually 71. So z alpha over 2 is here. Z 0.025 is 1.96. And sigma is a square root of 73 and e is 2. So if you simplify this one, you will get 71. 70.1092. So you will get actually 70.1092. But in this case, for the sample size, we'll always round up to the nearest integer. So the next integer is 71. So the answer will be then 71. Okay, so for our t curve with degrees of freedom 20, find the t value. So you need to actually look at that t table. So here the degrees of freedom is 20 and t is 0.01. So that's mean we are given this area is 0.01. So we need to find this t value. So this area will be then 0.99. So you have the degrees of freedom and you know the area on the right side of this t value, which is 0.01. So from the t table, you can find the t value. So here we do not have the table. So you can just look at the t table and you will get the t value. And which will be, I think 2.33 maybe, or you will check actually. You should check like which one is correct. Okay. So 30 randomly selected students took the calculus final. So here the sample size n is 30 and the sample mean x bar is 81 and standard deviation is 13.1. So find the 99% confidence interval. So alpha is 0.01. So we have to find the confidence interval. So degrees of freedom is then 30 minus 1, which is 29. So you need to find t alpha over 2. That's mean t 0.005. So you need to find this value where degrees of freedom is 29. Then the confidence interval is x bar plus minus t alpha over 2 times s over square root of n. So you will find this value. You have the x bar, you have s, which is 13.1, and you have the sample size is 30. So you will plug in all the numbers here, and then you will get the confidence interval. Do you have any question? Okay, so if you do not have any question, let's move to the next problem. So classify the hypothesis test as two-tailed, left-tailed, or right-tailed. So here a health insurer has determined that the reasonable and customary fee for a certain medical procedure is $1,200. They suspect that the average fee charged by one particular clinic for this procedure is higher than $1,200. So they want to perform a hypothesis test, and they are suspecting the average is higher than this one. So that's been the null hypothesis mu is 1,200, and alternative is what they are suspecting. They are suspecting mu is greater than 1,200, right? So that's when this is a right tail test because mu is greater than 1,200. If it is greater than the right tail, if it is less than the left tail, if you have not equal sign in the alternative, then it will be two-tail test. So this is right-tailed. Okay, so in the past, the mean running time for a certain type of flashlight battery has been 8.4 hours. The manufacturer has introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has increased. So they want to do a hypothesis test where null is 8.4 and alternative is mu greater than 8.4. So this is a right tail test. So explain the meaning of a type 2 error. So what do you know about type 2? Type 1 is reject null, reject H0 when null is true. And type 2 is fail to reject null when H0 is false. So this is type 2. FTR means fail to reject. So fail to reject null. So what does it mean? Fail to reject null means we are failing to conclude mu greater than 8.4. The average lifetime is more than 8.4 hours. We are failing to conclude this. In fact, the average lifetime is more than 8.4 hours. So this is the type 2 error. So that's been a type 2 error occurred if in fact mu is greater than 8.4, but resulting the sampling lead to conclusion that it is not okay. So a type 2 error would occur. In fact, this is 8.4, but the results fail to lead this conclusion. Yeah, this is the correct answer. So type 2 means this is correct, but we are failing to conclude this. So this is the type 2 error. So that's means option A is correct. So you might get confused with this one, this option and option D. Oh, sorry, option C. So why option C is not correct? Because we are not actually concluding this. Concluding mu is less than 8.4. We are failing to conclude mu greater than 8.4. So that's why the answer will be A. Okay, so the recommended dietary allowance RDA of vitamin C for women is 75 milligrams per day. Okay. A hypothesis test is to be performed to decide whether the adult women are on average getting less than this amount of RDA. So that's mean the hypothesis is mu is 75 and alternative is mu less than 75. So the answer will be then this one. Okay, the next one is the maximum acceptable level of a certain toxic chemical in vegetables has been set at 0.3 ppm. Okay, a consumer health group measured the level of the chemical in a random sample of tomatoes obtained from one producer to determine whether the mean level of the chemical is this tomatoes exceeds the recommended limit. So that's mean the hypothesis is here the null is 0.3, which is the recommended limit, and alternative is mu greater than 0.3 ppm. Okay, so this is our hypothesis. So now when mu is the mean level of chemical in tomatoes from this producer, suppose that the result of the sampling led to non-rejection of null hypothesis. So we fail to reject the null, classify that conclusion as a type 1 error, a type 2 error, or correct decision. In fact, the mean level of the chemical in this tomatoes is greater than 0.3. Okay, so our sample is leading us to non-rejection of this one. So non-rejection of this one means we fail to conclude this one, right? So that's when we made our type 2 error. So this is in fact correct, but we fail to conclude that mu is greater than 0.3. So this is a type 2 error. So we fail to reject null when null is false. Okay, determine the critical value for one mean z-test. So find the critical values for a right tail test where alpha is, so here alpha is 0.07. So the z value will be then, this critical value will be then this one. Find z 0.07 from the table. Okay, so now draw a graph that illustrates your answer. Then you will draw a graph that illustrates our answer. So this is a right tail test. So for sure, it will be, the rejection region will be on the right side. So it will be 0.07. So this is our rejection region, reject H0. And this one will be do not reject H0. And this is the critical value. So that's when this is not correct. This is not correct. So you have to choose either this one or this one. Okay. So now you will go to the Z table. You will look at 0.07, and based on this, you will get the Z score, critical value. Okay. So in this case, I think the critical value will be maybe 1.48. I'm not sure though, but you need to check it. Yeah, 1.48. So this is 1.48. So that's when the correct answer is C. Okay, the significance level and p-value of hypothesis test are given. So we are given the significance level and the p-value. So alpha is 0.10 and p-value is 0.14. Okay, so based on these two information, so do we reject the null or fail to reject the null? So what do you think? Should we reject the null hypothesis or we fail to reject the null? Anyone? So should we reject or fail to reject? Anyone?
Do not reject.
Yes, that's correct. Thank you. Because p-value is greater than alpha, right? So we reject when p-value is less than alpha. But here, this is 0.14 is greater than 0.10, right? So that's mean we fail to reject null. So we do not reject the null hypothesis. So in this case, we do not reject the null hypothesis. Okay, a sample mean, sample standard deviation, and sample size are given. Use one mean t-test to perform the required hypothesis test. So we have the hypothesis. This is left tail test. So we have to perform a one mean hypothesis test, where this is a left tail test because the alternative is mu less than 26 and alpha is 0.05. So we need to calculate Z alpha. Sorry, this is we do not have sigma, so actually we have to do t-test. So that's mean you have to calculate t alpha, t 0.05, and the test statistic will be then x bar minus mu divided by s over square root of n. So x bar is 24.4 minus mu 0 is 26, and sample standard deviation is 9.2 over a square root of 25. Okay, so if you simplify this one, then it will be 24.4 minus 26 divide 9.2 times So it will be then negative 0.87. So this is our test statistic. So that's mean this is not correct. This is not correct. Oh, sorry, not this one. This is not correct. So we have only two options, A and B. So now we need to look at the critical value. So they are almost same, negative 1.711, and this is negative 1.708. Okay. So this is 0. The critical value is T 0.05. Okay, negative 0.87. So it should be for sure somewhere here. So this is actually negative because the critical value is either negative 1.7 is negative 1.71. So that's means it will be 0.87 will be somewhere here. So we fail to, we do not reject null. Here we do not reject null. We do not reject null. That's correct. And there is no sufficient evidence to conclude the mean is less than 26. There is no sufficient evidence to conclude that the mean is less than 26. Yeah, so everything looks same. So the only difference is this one and this one. So the critical value. So that's when you have to find the critical value. So what is the degrees of freedom? The degrees of freedom is 25 minus 1, which is 24. So for degrees of freedom 24 and the probability is 0.05, you need to find the critical value TS score, which is negative T 0.05. Yeah, you have to find this one from the T table. Yeah, I do not know which one is the correct. Let me check. Maybe this one. No, this is not correct. So that's why the critical value is negative 1 point. So this value is negative 1.711. So you will get this one from the T table. Yeah, this is correct. Okay, researcher is interested in comparing the resting pulse rate of women who exercise regularly and women who do not exercise regularly. She wants to perform a hypothesis test to determine whether the mean resting pulse rate of women who exercise at least 6 hours per week is less than mean resting pulse. So that's mean basically they want to compare two means, right? So identify the variable for the proposed hypothesis test. So what should be the variable? So the resting pulse rate, the difference between mean resting pulse rate of women who exercise regularly and mean resting pulse rate of women who do not exercise regularly, and or hours of exercise per week and mean resting pulse rate. Okay, so which one should be the variable here? Actually, the researcher want to determine whether the mean resting pulse rate for women who exercise at least 6 hours per week is less than the mean resting pulse rate of women who exercise less than 6 hours per week. So what should be the variable in this case? Okay, so you said resting pulse rate. Okay, so let me check. Yes, the variable is resting pulse rate, right? Because so what is varying here? The resting pulse rate, right? So that's why the variable is this one. Okay, so the next question is the confidence interval for the difference mu1 minus mu2 between two population mean is given. The confidence interval is given. Now we need to interpret this confidence interval. So what does this confidence interval mean? this is between -40 to 230. And the confidence level is 98%. So that's mean we can be 98% confident that this difference is between -40 to 230. Okay, so what is the first one? We can be 95.8% confident that mu1 and mu2 both lie somewhere between. This is not correct. So we can be 98% confident that mu1 minus mu2 lies somewhere between 40, no, -40. So this is not correct. So we can be, okay. So the correct answer should be then this one, C. We are 98% confident that mu1 minus mu2 is between -40 and 230. Okay, summary statistics are given below for independent simple random sample. So now we need to construct the confidence interval, 95% confidence interval. So alpha is 0.05. And we are using pooled t interval. So pooled t interval means you have to use the formula, this formula. So test statistics will be then x1 bar minus x2 bar divided by sp square root of 1 over n plus 1 over n2. Okay, so where n1 is 14 and n2 is 17. Okay, so in this case, the degrees of freedom is n1 plus n2 minus 2. So this is the degrees of freedom. So you need to calculate SP. You have x1 bar, you have x2 bar. So you have all the values. Now you need to just calculate this one, SP. Okay, and the formula will be then x1 bar. Oh, this is the formula for test statistics, but for this one, it will be then the alpha over 2 SP over 1 over n1 plus 1 over n2. Yeah, so you have to use this formula to find the confidence interval. The formula for pooled t interval. Okay, the number of success and the sample size are given for a simple random sample. Determine the sample proportion p hat. So we have x, which is the number of success, and n is 40. So p hat will be then x over n. So which is 5 over 40. So that's mean this is 5 over 40, which is 0.125. So p hat is 0.125. So this is the correct answer. Okay, so in a survey of 5,900 TV viewers, 40% said they watch network news program. Find the margin of error for 95% confidence interval. So you have to find the margin of error E. So E is the alpha over 2 times sigma over square root of n, right? So 40% said they watch network news program. So now you have to, so how do you calculate sigma? So in a survey, this is the sample size. Okay, so find the margin of error for 95% confidence interval. So here alpha is 0.05. So you need to calculate the alpha over 2, which is 0.025. Okay, so to estimate the population proportion, so now you need to find the sigma for p hat. So which is the square root, sorry, sigma is the square root of p times 1 minus p. So that's mean it will be p hat times 1 minus p hat. Z alpha over 2, sorry, Z alpha over 2 times okay. So where p hat is here 40%, so that's means 0.4. And n is the sample size, which is 59, n is 5900. So that's mean if you plug in all the numbers, then it will be 0.4 times 0.6 divided by 5900, the square root of this, and times 1.96. So it will be 1.25%. So that's mean the margin of error is 1.25%. So if you simplify this one, then it will be, yeah, 1.25%. Okay, so the number of success and the sample size are given for a simple random sample from a population. Decide whether using 1 proportion Z interval procedure is appropriate. Okay, so to determine this, the n minus x and x, both of them should be greater than equal 5. So here n minus x, which is 90 minus 86. This is 4, which is not greater than equal 5, right? So that's mean not appropriate. So this one will be not appropriate. Okay, similarly for this one, the number of success and the sample size are given for a simple random sample. Use the 1 proportion Z interval procedure to find the required confidence interval. So you have to find the confidence interval. So to find the confidence interval, you need to use this formula. So here p hat is x over n, which is 30 over 58. Okay, first check whether Z interval is appropriate or not. It should be greater than equal 5, and n minus x also greater than equal 5. So x is clearly greater than equal 5, which is 30, and n minus x is 28, which is also greater than equal 5. So that's means the Z interval is appropriate. So now the confidence interval is p hat plus minus Z alpha over 2 times square root of p hat 1 minus p hat over n. So you need to use this formula to find the confidence interval. So where p hat is 30 over 58, which is 0.5172. Okay, so now we have the sample size, which is 58. You will plug in all the numbers here, and where alpha is 0.05, so alpha over 2 is 0.025. So Z alpha over 2 is 1 point. From the table, you will get this is 1.96. So you have p hat, you have p hat is 0.5172. So 1 minus 0.5172 is times 0.5172 divided by 58. Okay, so and then times 1.96. So if you simplify this one, then you will get actually 0.5172 plus minus. If you plug in all the numbers and simplify, then it will be 1286. So the upper limit will be then this one plus 0.5172. For the plus sign, you will get the upper limit, and for the minus sign, you will get the lower limit. So the upper limit is 0.646. So this is the upper limit, 0.646. So that's mean the correct answer is D. So here the correct answer is option D. Yeah, that's correct answer. Okay, so we are done with the review for multiple choice questions, but we have also another set of review problems, which is for short responses. And I think there are, I'm not sure how many problems are there. I think less than 10 problems are there. Yeah. So actually today we do not have time to go over those problems. So I'll try to go over those problems and record it and post it on the YouTube. Okay. So this is the end of this semester, and this is the last class. So good luck on your final. And if you have any questions or if you need any help, please email me. So I'll be happy to help you. Okay. And if you have any question, I'll be here for 5 more minutes. So if you have any question, you can ask me. Any question about your exams grade, quiz grade, homework, or final, then please let me know. Or if you need any help, then please email me so we can schedule a Zoom meeting. So if you need any help, okay.